Have you ever noticed how sometimes the latest, greatest technology feels weirdly familiar? Well, imagine working with the most advanced AI on the planet, only to realize it feels exactly like the software you were using 30 years ago. That's the bizarre experience of a programmer named William Weaver, and his story reveals something pretty amazing about tech. Sometimes the future is just the past, coming back around in a new way. And this quote? It just nails the journey we're about to go on. We're going to see how the same arguments, the same aha moments, and even the same feelings, they just keep echoing across the decades. We're connecting the dawn of the modern internet to the age of AI. Okay, so let's meet our main character, William Weaver. Picture this, it's 2025. He's in his lab, and he's working with some seriously futuristic tech. But as he's building this new instrument, he gets hit with this overwhelming sense of déjà vu. It feels identical to what he was doing 3 decades ago. So what's going on here? This slide really gets to the heart of the paradox. On the surface, what Weaver's doing looks effortless. I mean, he's just having a conversation with an AI. But underneath it all, the actual feeling of building, of problem solving, that feels just like his early days hunched over a keyboard. So what he's using is this powerful AI framework he calls Google Antigravity. And you can think of it like a conductor for a digital orchestra. It helps him manage a bunch of different programming languages all at once. C++ for the physical hardware, the nuts and bolts, Python for the server's brain, and Node.js for everything the user actually sees and clicks on. It's this incredibly complex system, and he's building it just by talking to an AI. Wild, right? All right, so to really get why this super futuristic setup feels so old school, we gotta jump in a time machine and rewind the clock 30 years. We need to see what tool back in the 90s created this exact same feeling of magic. First off, it is super important to know that Weaver wasn't some rookie. This guy came from a background of deep, roll-up-your-sleeves, hands-on coding. We're talking old-school languages like COBOL and Fortran. For his dissertation, he hand-coded over 21,000 lines in a language called Forth, manually managing every single little operation. This is a guy who knows how the machine really ticks. And then, in 1993, he stumbles upon a tool that would change everything: LabWindows/CVI. Imagine a digital workshop built specifically for scientists. Instead of just a blank, intimidating screen, it was a smart environment designed to help you build virtual instruments that could control real-world lab gear. And this is where that feeling of magic first showed up. CVI had features that were absolutely mind-blowing for the time. It had autocomplete, suggesting code as you typed. It had these things called function panels that would literally guide you through using complex commands. And, get this, it would automatically write all that tedious code you need just to create buttons and graphs. It was like having a spell checker and a grammar assistant for your code, all rolled into one. But, not everyone was impressed. The programming purists, the keyboard warriors who took pride in writing every single line from scratch, they saw this new tool as, well, cheating. They called it a crutch, basically saying it would make you a weaker programmer. So, was it really a crutch? Well, the numbers tell a very different story. In just 7 years, Weaver used this thing to generate over 100,000 lines of code for the Air Force Research Laboratory. And this wasn't for some simple website. This was for controlling high-speed cameras and complex laser systems inside wind tunnels, high-stakes stuff. And here's the crucial point. CDI wasn't doing the thinking for him. It was just handling the boring, repetitive parts, the grammar and punctuation of the code, what we call syntax. This freed up Weaver's brain to focus on the much bigger picture, the physics of the experiment, the architecture of the network, the system itself. Now, CVI was really just the beginning. The next leap forward in these tools led to what Weaver calls a golden era of innovation. But, as we all know, golden eras don't last forever. The next big thing was a tool called LabVIEW. And yep, that's pronounced LabVIEW. This was a total game changer. Instead of writing lines and lines of text, you were visually connecting blocks on a screen, like you were building a flowchart. It was just this incredibly intuitive way to think about how data flows through a system. And LabVIEW was a massive, massive success, especially in schools. Weaver found he could take university students who had absolutely no programming experience and have them building pretty sophisticated data analysis systems in just a few weeks. It basically democratized programming for a whole generation of scientists and engineers. But then, the cracks started to show. The company's visionary founder retired. A few years after that, Weaver's lab started hitting all these new bureaucratic roadblocks with the university's IT department. And then, the final straw. The company itself, National Instruments, got bought by a much larger corporation, Emerson. And these big corporate shifts, they had real on-the-ground consequences. The academic licenses that made LabVIEW so accessible suddenly changed. They dropped support for affordable third-party hardware. Key features just vanished, and even their new AI support system turned out to be totally unreliable. The tool was basically turning its back on the very people who had made it so great. The end result of all these roadblocks was simple, and it was devastating. Weaver's research lab, the SAIL team, came to a grinding halt. All that progress was just stopped in its tracks. And that brings us right back to today. After years of frustration and being stuck, a new solution finally appears. And it not only gets the research back on track, but it triggers that profound sense of déjà vu, bringing our whole story full circle. The solution is Google Antigravity. Now, this is not an AI that writes all the code for you. No, think of it as the ultimate evolution of that little autocomplete feature from 1993. It's an AI assistant that can instantly build out all the basic, repetitive setup code, what programmers call boilerplate, which frees up the human developer to focus on the high-level design. And this right here, this is the whole story in a nutshell. Back in 1993, CVI automated the annoying code for creating a simple window on a screen. Today, Antigravity automates the complex code for connecting to other services all over the internet. The technology is worlds apart, but the benefit is identical. It handles the low-level details so the expert can focus on the system. So, if the tools are constantly changing, from command lines to visual flowcharts to conversational AI, what is it that stays the same? The real takeaway here is that the programmer's ultimate goal, that has never really changed at all. For a scientific programmer like Weaver, the mission has always boiled down to these 3 steps. 1. Build something to capture the data you need. 2. Create a system to control the experiment with precision. And 3. Analyze all those results to find the truth hidden inside. That's it. That's the whole job. And Weaver himself really says it best. This goal has been the one constant thread through his entire career. The languages, the platforms, they're all just a means to an end. Whether he was hand-coding in Forth or he's chatting with a powerful AI, he's still just trying to build a better instrument to find the truth in the data. And this brings us to a final, really big question. For you, we've seen how each new layer of technology, from that early autocomplete to today's AI, frees up our human creativity to solve bigger and bigger problems. And the tools are only going to get better. So, what amazing things will you build? What huge challenges will you solve when you can focus purely on the system and not the syntax?